the thing is, the CapitalOne cloud adoption was a big deal because um, at the time, the cloud was a bit new, and making such a bold move was kind of a very high risk. Especially, there are some field that you evolve in, industries like banking or finance or government. They are very aware of the cloud, and they don't like to move because at the time the cloud was not very well understood, and people say that your data is going to be in a data center that you have no control about. So Capital One making this move at the time, and they were so proud of it. There was a lot of challenges and a lot of talk about that. So Capital One is a top 10 US bank in the US with more than a million of customers, and they are a cloud pioneer. So they migrated to AWS in 2020. So around 2019, 2020, it was a very big move for a banking company to move to the cloud because they always like to make sure they own their data to make sure that they are secure. So it was a very innovative thing for them to do. So um, as you know already, in the cloud, there is the EC2 instances, which are the virtual machine, and you have a WAF. A WAF is a web application firewall. It's basically a firewall, but for the cloud. So it protects your web-based application against any type of attack or malware. So when you have an application which is hosted in the cloud, you have a WAF instead of a regular firewall, which will be in a physical data center. The WAF is a web application firewall. And then you have your S3 bucket for storage and DynamoDB for your database. So what happened? In July 2019, CapitalOne discovered there was a massive data breach affecting millions of US customers, 6 million of Canadian customers, and then data that spanned 14 years. So between 2005 and 2019. Here we are talking about SPII. So SPII stands for Sensitive Personal Identifier Information versus PII, which is Personal Identifier Information. So the PII is like your email address, your physical address. But when we talk about your social security number, your date of birth, these are SPII, very sensitive personal identifiable information. And the other type of data, mostly for people in the healthcare industry, they talk about PHI, which is protected health information, like your health record. So imagine being a Capital One customer, and now all your data, social security number, your amount of money you have in the bank, on the dark web. So the attack was done by this old Amazon employee who did a SSRF attack. The SSRF attack is a server-side request forgery that I'm going to explain in a few minutes. So what the girl did, the hacker was a woman. So what she did, she exploited some metadata that were hosted in the EC2 instance, and she literally extracted some data from the S3 bucket that CapitalOne was hosting in AWS. So she started by accessing the data in the S3 bucket instance of CapitalOne, and then she copied all the sensitive data and downloaded everything. So the hacker is called Paige Thompson. She is a former AWS engineer with very specialized knowledge. So the reason she did that, it's because at the time, CapitalOne was bragging about moving to the cloud, and AWS not secure as she know it. She wanted to showcase that the cloud was not secure enough. So she exploited a vulnerability, which was a misconfiguration that the CapitalOne engineer made in their WAF, which is their web application firewall. So there was a misconfiguration within their WAF, and that allowed command execution, and then the IAM role had too much permission. So remember, in terms of cybersecurity, we need to always adhere to the principle of the least privilege, which is basically the basic rule in terms of cybersecurity. So the principle of the least privilege says that you must give a user account the strict minimum permission that they need. And this is called identity and access management. So in terms of identity and access management, there was too much permission given to some account, and then they were basically metadata available for the hacker to download. So remember, I explained how the hacker mindset works. You have an asset. This asset can be anything like a server, a firewall, something very valuable for you. Then you have the vulnerability. This vulnerability can be like a misconfiguration or a bug. By bug, I mean, for example, there is a security patch available for the software or the operating system for the engineer to download. For example, if the asset is a web server, the web server runs on Apache. So Apache 3.0 came out, and then you're still running on Apache 2.0, 2.1. So you did not upgrade to Apache 3.0, which brings a patch or a security update, so that means your Apache on 2.1 is still vulnerable to a specific attack. And then you have the risk here, because the risk is the intersection of the asset, the vulnerability, and the threat. And what is the threat? Obviously, it's the hacker. So, in terms of cloud security, you need to be sure that you do a risk management so that when you have specific vulnerabilities, you ensure that whenever there is a threat, and then you have also a perfect inventory of your asset. So you need to know what you have to make sure that you can protect your asset. And then this is what risk management is about: the intersection of the threat with the asset that you have and the vulnerability that your asset is having. When the hacker did that and the news started saying, oh, CapitalOne, which is a big bank, so the news was huge. It was a breaking news when that happened, and CapitalOne was breached. There was a data breach. So everybody started asking questions about whose responsibility it was. And that's why we studied the shared responsibility matrix, because in cloud computing, this is something very important. AWS from Amazon, they had to issue a statement saying, hey, we are a cloud service provider. We only provide the EC2 instance. It is the customer responsibility to configure properly their instance. And Capital One was blaming AWS because it was their responsibilities that the hack happened. But as we know, AWS has their own responsibility, there are shared responsibilities, and there are the customer's responsibilities. Depending on what type of service the customer purchased, whether it's a PaaS, a platform as a service, infrastructure as a service, a SaaS, software as a service. So depending on what type of service you purchase, you as a customer or as the organization, you have also your own responsibility. And in this case, AWS or Amazon, they were right, because what happened, it was a misconfiguration on the client side where, one, their WAF, their web application firewall, was misconfigured. And then, on top of that, the IAM role they assigned to the firewall had too much permission. And that's how the hacker was able to do server request forgery, which I'm going to explain in a minute. So, the breach. So, there was a class action of 190 million. So at the time, if you were a Capital One customer, you may have received money, and then you may have sued Capital One for letting your personal data go on the dark web or on the web. So there was a lot of cost for Capital One regarding this breach, including legal fees, technical remediation. So at the time, I believe the Capital One team had a dozen of engineers. They went from a dozen of engineers to 40 engineers working on the cloud computing department only. So they beef up their department, their cybersecurity department. So in terms of cost, Capital One faced a lot of damage also from a branding perspective in terms of image, which is harder to rebuild. So, Paige Thompson in 2019 was a former Amazon employee who executed the largest data breach in US history. And she was able to compromise personal information of over 100 million Capital One customers. And this lady is basically a geek. So she did that only, not for money, just for the fun of it. Basically there is 2 or 3 types of hacker. One, this is an activist, political reason. So there is something called cyber warfare. It's like when Russia or China is attacking US government for political reason. For example, China in the past has hacked the Pentagon information to steal design of their airplane, and then they literally reproduced the airplane, and then the US woke up one day and then, oh, China has exactly the same exact design airplane. So they did a hack, and they were able to steal these data. So the first type of hacker is an activist. The second one is that's it. This is his job. So he does that for money. So he hack for ransomware. They hack for money. This can be their full-time job. And the third type, it could be literally a kid in their dorm room playing around, and then, for example, a kid can log into their server at their high school just to showcase that they can do that. They can change their grade or change their final grade and just brag about the fact that, oh, I was able to hack the school system. So hackers do really that, just for the glory or the fun of it. But either or, whether you are the first one, the second one, or the third one, you're going to jail. Because if they catch you, you'll be in big trouble because it is prohibited to hack a company without their previous consent. I'm saying without their previous consent because you could hack a company for money. It's called pen testing. So you can become a pen tester, and this is a full-time job. So you have a consulting firm where you provide hacking services. At this time, you are called a white hat. So a black hat is someone that does that for bad reason. A white hat is an ethical hacker. So you can become a pen tester because you know how to hack organization. What you do, they pay you to hack the company, but the company already know about it. What are they trying to do? They're trying to see if there is any vulnerability before a real hacker finds it. So they will pay you to try to hack the company. So there is two different types of hack when you are a pen tester, an ethical pen tester. It can be a black box or a white box. The black box is when the company comes to you and say, hey, this is my company, www.cositech.com. Try to hack me. A white box is when they literally give you their IP address. They say, hey, I have a network. This is the range for the subnet. They give you some pieces of information, and then they will facilitate your hacking. So you're going to try to hack and get into the network. So it could be a white box or a black box. So this lady had obviously some mental issues, trouble of gender identity, a lot of depression and mental health issues, where she just wanted to showcase that she was good at what she's doing. So her name on the, so after she hacked the CapitalOne, she literally bragged about it on Twitter and posted, I did that. So obviously they went to her house, and if you're interested about that, this is called forensic analysis. This is an entire full-time job as well. You can be a forensic analyst, just like you see in the movie and the crime scene where people, in this case, they kill someone, but when they kill someone, you see they'll put these yellow cones and then put white gloves to not contaminate the scene. Is the same thing that happened also for when a hack happened. So they will come to your house with white glove, but instead of someone being killed, your computer is going to be the evidence that they are going to pick up, and then the hard drive need to be in the same state. They are going to take your computer with white glove, put it in a bag, and then go on the lab to examine how you did the hack, what happened, what IP address you use, etc. So this is Paige Thompson's story that did the hack. She's a software engineer. She was working for AWS between 2015 and 2016. So she knew a lot about AWS already. So she had a lot of knowledge in terms of settings and how AWS worked in terms of configuration. And basically, she wanted to show that the cloud was not secure, and she did it on purpose. Then bragged about it after she did it. So, all the data that Paige downloaded from the S3 bucket from Amazon, she posted all this data on GitHub. You know, GitHub is a public space, and everybody has access to GitHub. So basically, one day, all people's social security numbers were on the internet, on GitHub, and a bunch of personal identifiable information. So she also installed cryptocurrency mining software on the compromised servers, because, you know, for mining to work, you need a lot of computing power. So she literally used the Capital One servers to mine crypto. And then she accessed personal information of 106 million customers, including name, addresses, credit score, because Capital One has a service called Credit Rise that provide credit score. So people's credit score, social security numbers, really were on the internet. So Thompson breached at least 30 other organizations, causing an estimated damage of 250 million. Obviously, they arrested Tom Page after the FBI investigation on July 2019. On June 2022, she was convicted of wire fraud and unauthorized computer access charge. On October 2022, she was sentenced to serve time, about 5 years supervised release, and then in 2025, Ninth Circuit Court order a resentence. What happened usually with this type of hackers is that, for example, her sentence was a little bit light because they say that she had mental health issues, transgender status. Well, usually what happens is that when you're good at hacking and you did a bad thing, the FBI will most likely, instead of putting you to jail for a huge amount of years, they will try to convert you from being a black hat to a white hat. So they will give you a deal like, hey, do you want to do like 20 years in prison or work for us for free? So most likely what they do, they work for the FBI afterward, but on an ethic way, because you don't want to waste someone's intelligence because the person was doing for a bad reason, but their knowledge is still usable, and the government will usually use them forgery. So an SSRF is a vulnerability that allows hackers to manipulate a server into making unauthorized access. That's basically what she did. So you'll have access to internal resources, to protected endpoint, and external system. So how does a server-side request forgery hack work? Most likely, what they will do is, when you have a website and then you type the URL, and then most likely there is going to be a form, and then you can enter some data, right? A lot of websites have form or empty field that you can interact with. So remember when I was talking about database and SQL, I said that SQL is a request language that you can use to interact with the database, to retrieve data from the database. So normally, a normal person will enter, for example, if this field says name, they will enter the name, their address, etc. Right? So the server-side request forgery, what the hacker will do, instead of putting a regular information, they will literally enter a whole entire SQL request inside of the field. So can someone tell me and guess what will happen when you hit the submit button here? So you go to www.companyxyz.com. There is a dynamic form that for some reason you need to fill in. There's your name, etc. When you hit submit, what happened exactly? It's not it sends the information that you put in the form to the server, right? And the server, what is being hosted on the server? What do we have on the server? So all these data, they go to the server, right? This is the server. So what do we have on the server? Yes, but this information is hosted in what? A database. Good, very good. So, a normal request, what will happen, the form is going to save all this information in the database. So your name or whatever the address, etc. But what happened if instead you come and you're a hacker and inside of this, you put an entire SQL request. You say in the name field, which is empty, you type select star, which will select everything from star, which is star in this case should be the table name. So any table in the database, enter. Boom, what happened? So this field is going to be, so remember last week how I explained you the database is, right? So you have multiple tables in the database, and then each field has a primary key, and this is the name field. Now, instead of having your name, for example, Gael, to be saved in the database, in the table, the server is going to receive an entire SQL request. So what will happen when this information hits the database, it's going to return information that you should not see, which is classified or encrypted information. So when you hit submit, the server doesn't know that this is the type of information that you put. They should put their name, but instead, the server cannot make the difference between the SQL request. So when the SQL request, which is a normal way to interact with a real database, it's going to read the request and say, oh, but this is a SQL request. Let me return the information that they requested. And now what will happen if the database is not properly configured, if there is not security settings that are put in place the proper way, so the server will return information that they should not return. And this is what a server-side request forgery is, and Paige Thompson basically exploited a vulnerability. What was the vulnerability? The server was not properly configured in the web application firewall, and the IAM wall configured had too much permission. So she was able to exploit this side, which is the vulnerability. Well, imagine you're a kid and you come to your favorite fast food. And then instead, so there is not a human being, there is a robot that is taking your order. So there is a menu, burger, whatever, French fries. Instead of typing your normal menu, you know that the server has some cookies. Sorry, the kitchen, there is some hidden cookies in the kitchen. So instead of putting your regular menu, you told the robot cookies, but the robot is doing the exact same job, taking an order and bringing the information back. But the robot doesn't know that you're asking for a cookie. It will bring the cookie because it doesn't know that the cookie is prohibited for kids. So in this case, the robot is the server who are the website servers, like this friendly robot, which is designed to take order and fetch things from the kitchen. But if you're smart enough to trick the robot by asking cookies instead, then you're going to receive a cookie. So this is what an SSRF is and how a SSRF can lead to a data exfiltration. So in 2019, Paige identified a misconfiguration on the web application firewall in CapitalOne's AWS environment. She crafted that trick request. The to the WAF and to sending requests to AWS metadata services. And then she was able to steal temporary AWS credentials with extensive permission to CapitalOne's cloud resources. So the SSRF led to data expectation, which is a lot of personal identifiable information, which it's a very well-known and common cyber attack that you can do on web application. So, lesson learned. So, it's very important to configure your web application firewall properly to block these type of attack. Always implement the principle of the least privilege. So you need to make sure that you implement strict identity and access management role permission to limit who can do what. And then use IMDS version 2, which enable AWS metadata service version 2, which require session token and blocking this type of attack. And always monitor your network with tool like IDS or IPS, which are intrusion detection system or intrusion prevention system to receive alert when, for example, there is an attack like that happening. So the hacker sent the request CapitalOne vulnerable WAF credential exposed, and S3 bucket was able to access and sensitive customer data were stolen. So CapitalOne did fix the misconfiguration that was done by the engineer. Like I said, they revamped completely their security monitoring and vulnerability detection system. They put a lot of money, hiring a lot of engineers to fix their entire cloud infrastructure. And basically, this breach cost CapitalOne a very large amount of money. They even paid 80 million in regulatory fine for inadequate cybersecurity, because you're supposed to showcase, for example, if you have cybersecurity insurance and you did not do what you call your due diligence, which is making sure that you do your job on your side, then the insurance is not going to give you any money. And then, like I said, not only the lesson learned are to always implement a principle of least privilege, but also you need to perform regular cybersecurity audit, perform training for the engineer, and use automated tool as much as possible. So the thing is, we've seen during this class that cloud security is a shared, ongoing responsibility. Both the cloud provider and the customer, they have their job, their role to do in securing the cloud. Both, they need to do their own part for the cloud to be secure. Human error and misconfiguration can lead and cause breaches. Proper IAM configuration is very important for cloud security. That's why IAM role is an entire job. You can go on LinkedIn and find, for example, job title, IAM engineer. This is literally a full-time job. Regular audit. I am an IT auditor. I used to do IT audit. So when you do an audit on a regular basis, what your engineer may have missed or what they didn't see, an external eyes can see it and let you know. They will come review your cybersecurity settings and make a report for you on what they've seen. Because when you work on a daily basis on the system, you may not have seen what misconfiguration you have. So hiring an external firm or an external auditor, IT auditor, to audit maybe once a year your system is a very good thing. So, well, this is what I had for you. I thought it was going to be fun. So if you have any question, let me know.